In this video, we will be planning and doing the layout of an A-stable multivibrator. So we've got the circuit diagram on the left and the replica of a Vera board on the right hand side. So we will be building this project or planning it for the Vera board. We can see there we've got the circuit diagram, we've got the values of the resistors at the bottom of that page. R1 and R4 would be the same values, 2 and 3 would be the same values. We've got identical capacitors and transistors, and so even the LEDs are identical. Maybe we've got two reds, two greens, or a red and a green, but they will be doing the same thing at a different point in time in the circuit. And so just to identify what we have, we will use the symbols as shown and just start drawing them as per the plan. Again, I start with the component side of the Vera board, and I start drawing as they would make contact as well. So again, we can see the black dots is electrical connections where the track goes across horizontally, and so I just make sure that I have that connection. The next connection would be 3 points from the collector. The LED is positive, negative at least, and the cap I have now are 2 that I draw in, and I also label them as I carry on, just to confirm that I am busy with the correct component. I look at another point where there's 3 connections, so the R2 leg and C1 negative will connect with Q2's base and vice versa, and I just make sure that those connections are in place as I draw R3. The leg again goes with C2's negative. I've got the second LED in place, and then I've got R4 there, identical to R1. R2 and 3 is identical values as well. The second transistor now I'm putting in and making sure that those 2 legs at the bottom would be my negative. All the points on top would be the positive input, and I label where I will have my input wires or my input connected. That is my input there, probably either 9 or 12 volts depending on which circuit you build. I will not put voltage there for the sake of the project. Then I have to measure the output of both sides, because this is a on-off light system where when the circuit is active, the lights flicker on and off at different stages. When the one is on, the other one is off. So I have to measure this with a multimeter and an oscilloscope, and I need to know where to put the leads or the prongs of the testers. So output A or output 1, output B would be output 2, depending on what you write. Again, I confirm my connections. I'll make sure I've got 3 terminals there on that track, nothing else making contact. 3 terminals on that track, nothing else making contact with it. And this is important that you get this right, so that when you actually build the circuit physically, that you can confirm that your plan is also correct, and that you will take your practical task and now reference it to your planning. The planning being where we were just doing the drawing. Again, just confirming all my connections is correct as per the plan. and the last 2 points would be on the negative. Everything looks good. Now, like in a previous task, we have to transfer the components to the track side, which is the opposite of what we're looking at. So again, there we now just confirm first what it is we need to do, and we will just transfer the components as it is into a mirror or an opposite image onto the back side of the VeraBoard, or the shiny side. So we will just transfer. You can either do from right to left or from left to right, depending on whatever is your preference. I will probably look at the bottom drawing and say, okay, I will start on my left and transfer that to the right hand side of the top drawing. I will count the little dots and start plotting. And you can see there I'm drawing the resistor in exactly on the same point, but on the opposite side. And I will follow through with the dots. Again, we can, if you're familiar with this, it'll be easy. Otherwise, you just count the little dots and holes and start drawing in the symbols. And again, as accurate as possible, except for the connections must be 100% accurate. The components might be on different places, maybe a line or so apart, but the connections has to be accurate, because this will be your reference when you're physically building the project. So again, I'm just transferring, and as I transfer, I'm confirming that I've got the correct connections, because I don't want to make a mistake on the planning. If there's a mistake on the planning, then your project will be a failure. As I draw them, I label them to confirm I'm busy with the correct component. Q2, confirm where the base is connected, and we should have a replica of what's happening at the bottom, except for it is now at the back. I'm just referencing and making sure I've got the correct components on the correct places. That's my C1, R1, Q1, and there is my connections.